From the Maxwell equation, we know that the speed of light is given by c is equal to 1 over square root of epsilon naught times mu naught, and the value of this constant is equal to 3 and 10 power 8 meter per second. So what we means by the speed of light and materials mediums. So usually from the speed of light we means that speed of light in vacuums. Light is an electromagnetic wave which has both electric and magnetic field. According to Maxwell theory, all electromagnetic waves travel through free space, that is n vacuum, with same speed, and that speed we call the speed of light, and that speed is equal to, the value of that speed is equal to 3 and 10 power minus 8 the plus 8 meter per second. So the light waves can also travels in materials mediums, but what happen if light enter to a material mediums? So when light enter to a material medium, let's say for example this is the material mediums and the light entered into this medium, let's say this is a piece of glass and this is a light. So what will happen to the speed of this? The speed will be slowed down, and the reason and what is the reason and why the speed slow down, we will know this in the reason in this lecture. So we will start from the Coulomb's law, and we know that the electric force between the two charges is given by Q1 Q2 divided by 4 phi epsilon naught times r square. This is, let's say this is equation number 1, and this equation is valid for the force of repulsion or attraction between the two charges in free spaces. What if we place the same charges in a material mediums? Then this equation can be written as Q1 Q2 divided by 4 phi epsilon times, we will replace epsilon naught by epsilon and r squares. So this is equation number 2, and further we will modify equation number 2 as f dash is equal to Q1 Q2 divided by 4 phi epsilon into epsilon naught divided by epsilon naught into r squares. So these equations, this can be written as Q1 Q2 divided by 4 phi epsilon naught into r square into epsilon divided by epsilon naught, yes. So these equations, in this equation we know that in these relations this term is very important terms, and we will this terms epsilon divided by epsilon naught is called the dielectric constant, and it is denoted by K sub E. And next we have, and the unit of this constant is equal to Coulomb square into Newton divided by meter squares. So next we have to look for the magnetic field and the magnetic properties of the medium. So what happened if this is a small piece of glass, and if light passes or electromagnetic waves passes through this, so what will happen to the speed of the light? So now to check the effect of the magnetic properties of the mediums on the light, we need a new term which we call the relative permeability, and that relative permeability is denoted by K sub m, and the K sub m is equal to mu divided by mu naught divided by mu divided by mu naught, and from this equation we know that mu is equal to K sub m times mu naught. We have this is another equations, and let's say this is equation number 4, and let's say this is equation number Ke is equal to epsilon divided by epsilon naught. This is equation number 3. Sorry for the inconvenience. So we have find here mu and Ke, and from this Ke we can find from this value we can find the K epsilon is equal to epsilon naught into Ke. So we know that the speed of light in free space from the Maxwell equation is given by C is equal to V is equal to C V is equal to C is equal to 1 over square root of the mu naught and epsilon naught. So this is the speed of light from the Maxwell equations. So we have to put the values of these equations. Let's say this is equation this is equation number 5, and we have to modify it for the material medium. Let's say this V dash representing the speed in the material medium. So for the material medium, this equation will be modified as mu times epsilon. So this is equation number 6. Now we have to put this equation can be further written as V dash is equal to 1 over square root of mu naught times Ke into epsilon naught times this is m and this is Ke. So we can write it as 1 over epsilon mu naught times epsilon naught into square root of Ke and Km. And from the previous equation we know that this is equal to C. So this is actually the speed of light C. So further we can write it as V dash is equal to C into 1 over Ke into Km and whole square root. So this equation is can be further written as C divided by Ke into Km whole square root. And this is now the almost final equation, but we need some little bit modifications. So our final equation is V dash is equal to C divided by square root of Ke into K sub m. In this equation, K sub e is dielectric constant, and it is always greater than 1. So from this equation we can say that the speed of the light or any electromagnetic waves decreases when the light or electromagnetic waves enter into any material mediums. So this is the end of this lectures. So please like, shares and comments on the lectures that how I can improve it further. Thank you so much.